Hey maths guys, God is maths. Now I know index laws are normally one of those things at A-level everyone just kind of brushes aside because it's normally meant to be pretty straightforward. It's just GCSE stuff really, but I thought I'd put together a few questions that might just challenge you a little bit on your index laws, see how we get on. So first one, nice and simple. We're just going to do some simplifying. So we've got lots of fractions and negatives going on, but that doesn't make anything more difficult. You know that. If you know your laws, you're all good. So I've got my bracket with my power up here. So I know, you know, that if we multiply these powers together, so remember we've got to make sure we do our numerator and denominator both by -2 because it applies to everything that's inside the bracket. We're a little bit closer to simplifying our answer, okay? So if I multiply -3/2 times -2 becomes a positive, and the 2's cancel out, so I just get x cubed, nice and simple. Okay, if I do my denominator, I've got x to the power of a quarter. I'm going to do a quarter times -2 because the power applies to both. Remember, it applies up here and up here. So we're going to do a quarter times -2, which gets me x to the power of -1/2. There we go. So we've simplified so far. Now we just remember our basic rules of indices. It's normally the second one we learn, I think, from what I remember. We're going to do x to the power of 3 minus -1/2. Okay, we're dividing, we're going to subtract the powers. And if we do 3 minus -1/2, we get x to the power of 7/2. There we go. Pretty easy start, okay? I know that. So this time, we're going to solve an equation. So we've got the fourth root of all of this stuff going on under here, equal to a cubed. So we'll try and do some simplifying. So if we have a look underneath the root sign, we've got two things with the same base multiplied together. You know what that means. We're going to add those powers. So if I do a to the power of x plus 2 plus 3x minus 1. So if I add x and 3x, I get 4x. If I add 2 and -1, I get +1. Okay? But that wasn't the only thing, right? It was underneath the root sign, but it wasn't a square root. It was a fourth root. So we're going to put our bracket around that and convert that power of a fourth root into 1/4. Right? It's our classic taking a root. So we put 1 over the root that we're taking, 1/4. Still equals a cubed. So now, like we had in the first one, we've got power of a power. So we're going to multiply this together. Now we treat the 4x plus 1 like it's a bracket because it is the whole power, and the whole power needs to be multiplied. So we've got 4x plus 1 times a quarter. So if we do that, we've got a to the power of 4x times a quarter would just be x, and then 1 times a quarter would just be a quarter. And that still has to equal a cubed. We haven't done anything to the a cubed. It's kind of floating around there waiting for something to do. So now, because we've got the bases the same, now we can equate our two powers. So we've got ourselves a nice simple equation to solve where x plus a quarter has to equal 3. So we just put our powers together. So in that case, then we get x equals 3 minus a quarter, a little bit of fractions. I won't tell anyone if you put it in a calculator. That would be 11/4. There we go. Not too bad. Okay, index laws, pretty light work. Probably save the easiest one for last. Oh, look, we're just adding some stuff together. This looks nice and simple. The number of times I've seen students look at this and say, oh, yeah, 5 to the power of 10x. Because they see all these 2x's and they just say, oh, I'm going to add them. These are all plus signs. Remember, you add the powers when you multiply. So this is no good to us. We can't just add those powers together. We have to try and think of something else. So it's not a coincidence that there are 5 of these, which means I could rewrite this left-hand side as 5 times 5 to the power of 2x. Looks a bit more useful. Still equal to 5 to the power of 8x minus 2. Haven't changed that. And now, if I do 5 times 5 to the 2x, if we're struggling, I'll give you a hint. Remember, this 5 has a 1. We don't normally write it. It's just 5 to the power of 1. So if I'm now multiplying these together with the same base, I can add them. I can add those powers together. 5 to the power of 2x plus 1 equals 5 to the power of 8x minus 2. Same base. I can now just equate my two powers together and find out what I need x to be. So let's squeeze that in this little space over here. So we've got 2x plus 1 needs to equal 8x minus 2. Nice simple linear equation to solve. So in our case, then we've got 2x. We take away this from this 8x over here. We get a 6x. 1 add 2 gets us 3. Divide it by 6, and we get x equals 1/2. So there you go. That was some of our index rule stuff. Easy to overlook at A-level because we assume we're confident, but always worth challenging yourselves a little bit. Remember, like and subscribe for more maths content from me. Awesome job, as always.